A very interesting theorem about the angle between a tangent and a chord. It says if a line touches a circle, for example here T dash PT is a line which touches the circle at point P, and from the point of contact a chord is drawn. PR is a chord which is drawn through this point of contact. So please just look here. I'll draw another figure for you. Like this is T dash PT, and this is a chord drawn PR. Now this chord PR divides the circle into two segments. One segment is this one, major segment, this is minor segment. He says if a line touches a circle and from that point of contact a chord is drawn, the angles between the tangent and the chord are respectively equal to the angles in the alternate segment. What are alternate segment? Now there are two angles which are formed. One is angle T dash PR, another angle is RPT. There are two angles between the chord and the tangent. So there are two segments, one segment is this side, one segment is this side. So he says this angle X will be equal to this angle X, and this angle Y will be equal to this angle Y in the alternate segment. Let us see what is given. T dash PT is a tangent. T dash PT is a tangent to the circle at point P. PR is a chord. S and Q are points in the alternate segment. S and Q are the points in the alternate segment. They are in the alternate segment. I showed you here what are the alternate segment. Alternate segment to this angle and to this angle, this is the alternate segment. So he wants you to required to prove is that angle RSP will be equal to angle RPT, where I have drawn this angle as X shown, this angle will be equal to this angle. And similarly he said angle RQP, this is the angle in the alternate segment, RQP will be equal to RPT dash. It will be RPT dash. What we have done, the construction, we have joined P to O, the center of the circle, and extended to cut it circle at point A and join A to R. We have joined A to R. Now let us see what are we going to do. We are saying angle PRA is or ARP is 90 degree. Why? Because angle in a semicircle. Why is it a semicircle? Because PA is a diameter. Because we have joined P to O and extended it to point A. So POA becomes the diameter. Diameter divides the circle into two equal halves, and each half is called a semicircle. And we have read the property that angle in a semicircle is always a right angle. So angle ARP will be 90 degree angle in a semicircle. Now look into the triangle APR. One angle of the triangle is 90 degrees. So sum of the remaining two angles should be how much? 90 degree as well. Because the sum of all the three angles, interior angle of a triangle is equal to 180 degree. When one angle is 90 degree, the sum of the remaining two angles should be 90 degree as well. That is what I have written. Angle PAR plus angle APR should be equal to 90 degree. This we obtain from the property that angle in a semicircle is right angle. The another property which we are going to use is that this T dash PT is tangent and this PO or PA is diameter as well as radius. So what is going to happen? Tangent and the radius are perpendicular to each other. They are perpendicular to each other. So angle APQ or angle APR, angle APR plus angle RPT, APR plus RPT will be equal to 90 degree because tangent and radius are perpendicular to each other. So that angle APT will be 90 degree. The complete angle APT is 90 degree. I have taken APT as sum of two angles, APR and RPT. APR plus RPT is 90. PAR plus APR is 90. So both the sum of these two angles and sum of these two angles are equal to 90 degree. So we are going to put them to equal to each other. We will say angle PAR plus angle APR will be equal to angle APR plus angle RPT is equal to 90 degree. In this, one angle is common, APR is common. APR is common in both the triangles, both the sides. So I take out APR and what is left? Angle PAR is equal to angle RPT. Angle PAR is equal to angle RPT. That means if this angle is X, this angle is X. But if this angle is X, then angle RSP will be also X because these are the angles in the same segment. That is the next step I have written, that PAR is equal to PSR. So PAR is equal to RPT also and PAR is equal to PSR also. That means PSR and RPT are equal. PSR is equal to RPT, which was the first thing which we had to prove. This angle is equal to this angle. The angle between the chord and tangent is angle in the alternate segment. Now, this angle is X, so this angle will be 180 minus X. This angle will be 180 minus X. Why will it be 180 minus X? Angle PQRS is a cyclic quadrilateral. PQRS is a cyclic quadrilateral and the opposite angles of cyclic quadrilateral are supplementary. So PQR will be 180 minus X. This angle will come out to be 180 minus X. And I need to calculate this angle. This is X, so this will be also 180 minus X. Why? Because T dash PD is a straight line. T dash PT is a straight line. So this angle also comes out to be 180 minus X. Now this angle in the alternate segment, the minus segment, is equal to this angle between the chord and the tangent. This is what we had to prove. So we are going to do a problem based on tangents. We have discussed the theorems on the tangents. The first theorem, if you remember, about the tangent was that if two tangents are drawn to a circle from a point outside, you can draw two tangents to a... We had shown you three things. One was that if a point is taken inside the circle, no tangent can be drawn. Then we had taken a point on the circumference of the circle and we told you that only one tangent can be drawn at a point on a circumference of circle. The next was that if a point is taken outside the circle, so from that point we can draw only two tangents to the circle, and those two tangents which are drawn from an external point to a circle are of equal length. So we are going to use the properties of tangent to solve the problem, and the problem is here that a circle is inscribed in a quadrilateral ABCD, or you can say that ABCD is a quadrilateral which is circumscribing a circle. Both the things are same, said in a different way. What does it mean that a circle is inscribed in a quadrilateral? When we are saying a circle is inscribed in a quadrilateral, it means all the sides of the quadrilateral are touched by this circle internally. For example, the side BC is touching at point G, the side CB is touching at point F, AB is touching at E, and AD is touching at H. That means this line AB is a kind of a tangent to the circle, AC is also tangent to the circle, CB is also a tangent to the circle, and DA is also a tangent. A straight line touching a circle at one point only is called a tangent. This is the basic explanation. Now what is he wanting? He wants you to prove that AB plus DC, AB plus CD or DC, AB plus DC will be equal to AD plus BC. We have to prove AB plus CD is equal to AD plus BC. I have written certain things. I have written DG is equal to DH is A, because D is a point, external point. From this point D, I have drawn tangent to this circle here, and I have drawn tangent to this. So the length of the tangents will be equal. That means DG will be equal to DH, and I have assumed this length to be A for convenience. Later on you will find it why I have done so. It will be easier for you to understand. DG is equal to DH. Similarly, CG will be equal to CF. Again the same property we are using, that C is an external point, and from that external point I have drawn two tangents to the circle, and both these two tangents are going to be equal in length. So CG is equal to CF, I assume it to be B. Now from point B we have drawn two tangents, BF and BE, and BF and BE will be equal as well. BF and BE both are equal to C. BF and BE both are equal to, I have written it D here, we should write it C here, because in the figure we have shown it to be C, and this should be D. And AE and AH are D. AH and AE are D, they are of the same length as well. So we have calculated, we have written everything in terms of A, B, C and D. And if you see what is AB, AB is D plus C, and DC is what? A plus B. A plus B plus C plus D. That means AB plus CD is A plus B plus C plus D. Similarly, if you see AD plus BC, what is it? A plus D plus C plus B. So it is what? A plus B plus C plus D. So AB plus CD as well as AD plus BC is equal to the same summation of the same letters, alphabets A, B, C and D. A plus B plus C plus D, A plus B plus C plus D. So AB plus CD will be equal to AD plus BC, and that is what we had to prove. So we have used the property, the tangents drawn from a point outside the circle to a circle are of equal length. DG is equal to DH, CG is equal to CF, BF is equal to BE, AH is equal to AE, and we have given them names ABCD to make it simpler for you. This is another problem based on tangents. ABC is a right angle triangle, right angle at A, it is right angle at A. AB is 12 centimeter, AC is 5 centimeter. There is circle inscribed in this triangle which is touching the three sides at point P, Q and R. We have to find out the radius of the circle. If it is X, we have to find the radius of the circle. We assume X to be the radius, so O to P, O to R, O to Q, all are radii, because we are drawing a perpendicular from O to P, O to R and O to Q. Tangent and radius are perpendicular. So this figure OQAP or OPAQ will be a square, because all angles are 90 degree and two sides are already equal. This OP and OQ are equal. This is X, the radii of the circle. So, and all angles are 90 degree. So these two sides AQ and AP as it is will be equal, because these are tangents drawn from point A to P and A to Q. So AQ and AP will also become X equal to this because it is a square. Now this complete length AB is 12 centimeter. The complete length AB is 12 centimeter. So I can calculate PB to be how much? 12 minus X. This will become 12 minus X. And this will also become 12 minus X. Why? BP will be equal to BR. BP will be equal to BR because we are drawing two tangents from B to the circle. So BP and BR are tangent, they are going to be equal in length. Similarly, this is X, this total length was 5, so it will be 5 minus X, so this will be 5 minus X as well. CQ and CR each will be 5 minus X because CQ is a tangent and CR is a tangent drawn to the circle from the same point C. So CQ and CR will be equal, AQ and AP are equal, BP and BR are equal. And by Pythagoras theorem, because two sides of the right angle triangle are known, with the help of Pythagoras theorem, I can calculate the third side. Like BC square will be AB square plus AC square, 12 square plus 5 square, 12 square is 144, 5 square is 5 square is 25, so 144 plus 25 is 169, square root of 169 will be 13 because generally we take out the modulus when we are taking a square root, so it will be positive only because we are talking of the positive side. Now we are talking of the sides. Now we have explained all what I have already spoken to you. CQ is equal to CR is 5 minus X, BP is equal to BR is equal to 12 minus X. Tangents drawn to a circle. Tangents drawn to a circle from an external point. From an external point. From an external point. Similarly, this PB is equal to BR is equal to 12 minus X, tangent drawn to a circle from an external point. So BC will be CR plus BR, which will be 5 minus X plus 12 minus X, and BC I have calculated to be 13 with the help of Pythagoras theorem. So 13 is equal to 5 minus X plus 12 minus X, and I will bring X to the left hand side. Minus X will be minus 2X. When it comes to this side, it becomes plus 2X, and it will go to that side. 15 plus 5 plus 12 is 17. 17 minus 13 is 4. So 2X is 4. So X will be 2 centimeter. That is the radius of the circle. This is another problem based on tangents. A circle with center O is inscribed in a triangle. Angle A is 60 degree. He says find angle QOR and find angle QPR. From O, if I drop a perpendicular on this, or if I join the point of contact, obviously it will be perpendicular because this is a tangent. If it is touching, then this is a tangent. Similarly, this is touching. Whenever we are saying a circle is inscribed, that means AB is tangent to the circle at point R, AC is tangent to the circle at point Q, and CB is tangent to the circle at point P. So we are going to say that angle ORA is 90 degree. Tangent and radius are always perpendicular. So angle ORA will be 90 degree. Similarly, angle OQA will be 90 degree. ORA is 90 degree, tangent is perpendicular to radius. Angle OQA is 90, again the same property, the tangent is perpendicular to radius. Now I have got this angle is 60, this is 90, this is 90. I have to find the fourth angle of the quadrilateral. The sum of the interior angles of a quadrilateral is 4 right angles, that is 360 degree. So the fourth angle can be calculated by subtracting the sum of these three angles from 360 degree, and those angles were 90, 90 and 60. So 90 plus 90, 180, 180 plus 60 is 240 degree. So 360 minus 240 will give us 120 degree. So we got the angle QOR as 120. That is the first thing he wanted. Now look, in the circle, the arc is making, this arc QR is making angle QOR at the center, and the same arc QR is making angle QPR at the circumference of the circle. So we had read the first thing, double angle property. The arc, the angle subtended by an arc at the center of the circle is double the angle at which it subtends at the remaining part of the circumference. Like this arc QR is subtending an angle QOR at the center, it will be double of the angle which it subtends at the remaining part of the circumference, that is QPR. So the relation is QOR is double of angle QPR. That is what we have written. QOR is double of QPR. This is called double angle property. Now this QOR was 120 degree. 120 degree is equal to double of QPR, or QPR will be how much? 120 upon 2, that is 60 degree. So we have got both the angles. We wanted the first angle to be QOR, which has come out to be 120 degree, and this angle QPR has come out to be 60 degree. In this question we have a circle with center O. AT is a tangent drawn to it, AB is the diameter, B is joined to T, and this angle AOC is 70 degree. We have to find the value of angle X. We have to find the value of angle X. So what are we going to use? The first thing is that since BA is the diameter and AT is tangent, that means angle BAT will be 90 degree. Tangent is always perpendicular to the radius. Tangent perpendicular to radius. In the short form I am writing radius. Tangent is perpendicular to radius. So this angle comes out to be 90 degree. Now I would say that angle AOC will be double of angle ABC. Double angle property. Angle subtended by an arc. Arc AC is subtending an angle AOC at the center. Arc AC is subtending an angle AOC at the center, and the same arc subtends angle ABC at the circumference. So the relation is that angle at the center is double the angle at the circumference. This angle AOC is given as 70 degree, will be double of ABC. So angle ABC will be 35 degree, half of 70 degree. This is double angle property. This is double angle property. Now we have got this angle to be 35. Now in triangle ABT, I can calculate angle X as 180 minus 90 plus 35. Sum of the interior angles of a triangle is always going to be equal to 180 degree. So 180 minus 90 plus 35, that will be how much? 55 degree. Sum of angles of a triangle. Sum of angles of a triangle. These are reasons you should write always. Sum of angles of a triangle is 180 degrees. So we have got everything. We have used the property. Number one, tangent and radius are perpendicular to each other. Number two, double angle property. The angle subtended by an arc at the center of the circle is double the angle which it subtend at the remaining part of the circumference, then we say that the sum of the angles of interior angles of a triangle is 180 degrees. From that we got the value of x to be 55. In this problem we have a circle inscribed in a triangle ABC, and the circle is touching AB at P, BC at Q and AC at R. He has given us the values AP as 5 centimeter, BP as 7 centimeter and AC as 14 centimeter. He wants us to find BC. Now AP will be equal to AR, AP will be equal to AR will be equal to 5 centimeter. Why? The tangents are of the same length. Tangents are drawn from A to the circle. AP and AR are tangent drawn, two tangent drawn to the same circle. They will be of the same length. AP is equal to 5, AR is 7, AR is 5. Then BP will be equal to BQ. BP will be equal to PQ will be 7 centimeter. Same logic. Tangents drawn to a circle from point outside are of the same length. BQ is 7, BP will be 7. This total line length was AC was 14 centimeter. So I can calculate CR. CR will be 14 minus 5, that is 9 centimeter. And CR will be equal to CQ. CR will be equal to CQ will be 9 centimeter. Hence, if you want to calculate BC, BC is BQ plus CQ, that is 7 plus 9, 16 centimeter. We are using simple property of the length of the tangents. If tangents are drawn from a point outside the circle to a circle, they are always of equal length. BQ is equal to BP, AP is equal to AR and CQ is equal to CR. Using that property we have got this. Thank you.